Welcome, guys. Have you ever noticed how some people finish tests faster than others? Like running a race? What's the difference? It is not just energy. They are using power. The faster work is done, the greater the power. Previous videos have discussed work and energy in detail, and today we will look at power. Now let's look at the concept of power. In a general sense, power is the rate at which work is done or energy is transferred. Now let's look at the formula for power. Since we define power to be work done or energy transferred, therefore the formula for work is work done or energy transferred divided by time. That is the rate at which work is done. Therefore, power is equal to work done over time, where P is the power, W is the work done, and T is the time. Remember from our previous video, we did say that the unit of work is in joules, while the unit of time, T, is in seconds. Therefore, the unit of power is in joule per second, or the watt, being the SI unit of power. Therefore, 1 watt is equal to joule per second. Other units of power are the kilowatts, where 1 kilowatt is equivalent to 1000 watts. That is 10 raised to power 3 watts in standard form. Another unit of power is the megawatt, where 1 megawatt is equivalent to 1 million watts. In standard form is 10 raised to power 6 watts. Another unit of power is the horsepower, where 1 horsepower is equal to 746 watts. All these are units of power. Before we proceed, let's lay the foundation for power by giving a brief recap of work and energy. In our previous video, we defined work as a force which acts on an object, causing it to move in the direction of the force. That is, work, W, is done when a force, F, acts on object, causing it to move in a direction, which talks about displacement of the force. So this brings us to the formula of work, which is force times displacement. When work is done under gravity, the formula changes to work done equal mg, where m is the mass, while g is the acceleration due to gravity. That is when the displacement is in the horizontal direction. If the displacement is in vertical direction, our work done formula will be mg sine theta multiplied by displacement. So any of these formulas could be applied when solving a numerical problem involving work done. Some key points. Work is positive when force and displacement are in the same direction. The second key point is that work is zero if there is no displacement or if the force is perpendicular to the displacement. That is when motion isn't in the same direction with the applied force. Let's look at energy. We did define energy in our previous video as the ability or capacity to do work or cause a change. And we say energy comes in various forms. First one being the potential energy, which we define as energy of position or stored energy. The second form being the kinetic energy, also known as motion energy. Now let's link power to work and energy. Since we say the formula for work done is force multiplied by displacement, while power is work done over time, therefore power can also be expressed as force times displacement over time. Remember, we did say since power is work, which is force times displacement over time, which is equal to force times, here we have displacement over time. Displacement over time talks about velocity, v. Therefore, power can as well be force times velocity. So force times velocity or speed is another way of expressing power delivered to our body by a force F, which acts on it. So one could use any of these formulas in solving numerical problem involving power, depending on the given parameters in the question or problem. So power could be work done over time, or force times displacement over time, or force times velocity or speed. Now let's look at how to calculate power. The first practice problem says that a person does 200 joules of work in 4 seconds. What is their power output? Firstly, we'll write the given parameters. We're told that the work done is 200 joules. So we have W, that is 200, in 4 seconds, that is time. So we look at these three formulas for power and look at for the one that has W and T. The first one here has W and T, that is work and time. So we apply this formula in calculating the power output. So power is equal to work done, and the value is 200 over time. Our time is 4, So 200 divided by 4 gives 50 watts. Remember, we did say the unit of power is watt. Therefore, their work output is 50 watts. Now let's look at the second example problem. A car engine produces 3000 watts of power to maintain a speed of 20 meters per second. What force does the engine exert? Now let's write out the given parameters. We are told that the car engine produces 3000 watts of power. So power is given to maintain a speed of 20 meters per second. So speed or velocity is given. What force does the engine exert? So we are to look for the force. Looking at the three formulas for power, power is given. Another parameter given is the velocity v, and we are asked to look for F. So this formula is suitable to answer this question. That is power equal to force times velocity. We have power. The power value given is 3000 equal to F times the velocity given is 20. So we have 3000 equal F times 20 gives 20F. Remember, what we are asked to find is the force F. Therefore, force equal 3000 divided by 20, which is 150. Therefore, the force that the engine exerts is 150 Newton. Remember, the SI unit of force is in the Newton. If you are getting value from this video and yet to subscribe to my channel, please kindly hit the subscribe button and turn on the notification bell. Also, do well to share this video with anyone who might find it useful. Thank you. Now, let's look at the third challenge. A 100 kg man is to run up a 30-degree incline at a steady rate of 1 horsepower. How fast must he be to do work against gravity at this rate? As usual, we'll write out the given parameters. We are given the mass of the man being 100 and our angle theta, that is 30 degrees, and we're also given the power, that is 1 horsepower. Earlier in this video, we did say that 1 horsepower is equivalent to 746 watts, and we're asked to look for how fast the man must be to do work against gravity. How fast in this context refers to the speed or velocity v. We have power here. Looking at these three formulas, remember we are asked to look for v, that is the speed or velocity. So we'll make do with this formula. That is P equal F times V. We are told that the man ran up an inclined plane. This entails vertical displacement sin theta, that is sin 30 degrees. That is our force F will be expressed as mass times acceleration due to gravity G times sin theta. So force will be mass, our mass value is 100 times G means acceleration due to gravity, and the value is 9.8 times sin theta, that is sin 30 degrees. So force will be equal to 100 times 9.8 times sin 30 degrees gives 0.5. So 100 times 9.8 times 0.5 gives 490. So the force value is 490 Newton. Remember, we are working with this formula. Now we've gotten our value for force. Remember, in our question, we are given power, and the power is 746 watts. Now let's find the speed v by substituting these values into the formula. So we have P, that is the power value, equal to F and then times V. So we have 746 equal 490 times V gives 490 V. Therefore, V will be equal 746 divided by 490. Therefore, how fast the man must be to do work against gravity is 1.52 meters per second. I hope this video helps. So guys, I have a question for you today. The question goes this way. If two machines do the same test, which is more powerful? The one that takes less time or the one that takes more time? And why? Please drop the response to this question in the comment section. And don't forget to share this video with anyone who might find it useful. Comment with any question or topics you want us to cover in future videos. Give this video a thumbs up. And if you are yet to subscribe to my channel, please kindly hit the subscribe button and turn on the notification bell. Thanks so much for watching. See you in our next video. Bye.